Good morning. Hello and welcome everyone. In today's world where digital ecosystems are expanding faster than ever, security can no longer be a afterthought. It must be engineered, built in, not bolted on. I am thrilled to invite you to a comprehensive 12-part video series on security architecture and engineering, a foundational and advanced exploration that bridges theory, practice, and governance. Whether you are a student beginning your journey, or a cybersecurity practitioner refining your craft, or a compliance professional aligning systems to regulatory mandate, this series has been thoughtfully created for you. In phase 1, we set the groundwork with core concepts. We unpack security models like Bell-LaPadula, Biba, Clark Wilson. We understand system architecture and its principles, including the trusted computing base and the reference monitors. We'll explore preventive, detective, and corrective controls, evaluate systems through common criteria, TCSEC and ITSEC, and dwell into cryptographic design and secure system components like hardware, firmware, and softwares. That's phase 1. In phase 2, we move into deep technical exploration. Here, we explore security design principles like defense in depth, least privilege, and fail secure. You learn about enterprise architecture frameworks such as SABSA, TOGAF, and ZACMAN. We'll also cover secure coding, SDLC security integration, engineering focused vulnerability management, and dwell into architecture for embedded systems, IoT, mobile, cloud native platforms, and containerization. You will gain insights into hardware based securities like TPMs, HSMs, secure boots, and trust zones, as well as emerging domains like zero trust architecture, confidential computing, and the impact of AI ML on architecture. In phase 3, we'll turn the spotlight to real world relevance through threat modeling methodologies like STRIDE, DREAD, and PASTA. We will analyze actual breaches, what went wrong, and what could have gone right. These case studies will contrast vulnerable versus resilient architectures, giving you blueprints for building secure enterprise patterns while avoiding anti-patterns that exposes organizations to risks. Finally, in phase 4, we will converge technology with governance. We will explore how to map architectural design to standards like ISO 27001 Annex A, NIST SP 800-160, and others. We learn how to perform architecture level risk assessments and how to design systems that are not only secure but compliant with global regulations like GDPR, India's DPDP Act, HIPAA, and PCI DSS. Each episode is crafted with clarity and depth, backed by real world examples, theoretical models, and regulatory insights. My goal is to demystify complex security concepts, empower you to design defensible systems, and help you think like a security architect. So, if you are passionate about building systems that are secure by design, resilient by architecture, and governed by compliance, this series is for you. Please subscribe, follow along, and join me in this transformative journey into security, architecture, and engineering. Let's build a safer digital world, one secure design at a time. This is your host, Savit Vittal Salian. Namaskar. Security, architecture, and engineering. Part 12. AI and machine learning in security architecture. Artificial intelligence and machine learning are being used to detect threat faster and with greater accuracy. They can analyze large amount of data to find patterns of malicious behavior. AI ML tools can automate responses to threat, improving speed and reducing human errors. AI and ML are increasingly integrated into modern security architecture to detect, respond to, and predict threats faster than traditional methods. They are used for anomaly detections, threat intelligence enrichment, user and entity behavior analytics, automated incident response, and are used for fraud detection. Example, a large enterprise deploys machine learning based system to monitor its user and network activity. So how it works? Well, ML algorithm baselines normal user behaviors which include login, file access, network traffic. So when a user begins downloading large volume of sensitive data at odd hours or accessing unusual the system flags it as anomalous. The security team is alerted in real time and automated control like session suspension or MFA prompts are triggered. The benefit? The company detects insider threat and compromised accounts before damage is done without relying on static rules. Real world example? Well, Darktrace uses AI to power its antigen platform, an autonomous response technology. It's used in a financial institution wherein AI model learns what normal looks like for users, devices, and systems. So when a malicious script starts scanning internal system, Antigena detects the deviation instantly. It automatically isolates the affected machines from the network and notifies the SOC for investigation. Advantage? Well, real-time mitigation with minimal false positive and no manual interventions were required. A big advantage. Application of AI ML in security architecture. It helps with intrusion detection, email security, access control, SIEM and SOAR, threat hunting, and fraud prevention. So, using AI ML application, they can use for creating behavioral baselines and thereby spotting any anomalies. It helps in detecting phishing and malicious attachments. It helps with risk based adaptive authentication. It helps with correlation and automatic triage. It helps with pattern recognition across logs and telemetry. Helps with real time transactions scoring in banking systems. Let's look at other emerging technologies. Emergent technologies like blockchain, quantum resistant cryptography, 5G security enhancement, and digital twins are reshaping how security is architected at system and infrastructure level. These technologies often augment or complement traditional controls with new models of trust, integrity, and resilience. Quantum cryptography. It's a new form of encryption based on quantum mechanics. It promises very strong security but is still in its early stages. Blockchain, it offers decentralized trust and transparency, useful in securing transactions and verifying identities. 5G security, that's the next generation mobile networks requiring new approach to secure data, device and infrastructure. So, hardware security and emerging technologies are essential for staying ahead of modern threats. They add powerful tools and techniques to the security architecture toolkit. Example, a multinational manufacturer implements a blockchain based system to secure its global supply chain, wherein every shipment is logged into a permissioned blockchain by authorized vendor. Cryptographic hashes ensure tamper evident records of material and components. Smart contracts automate quality validation and supplier accountability. Benefits? Well, data immutability and auditability. The big benefit. Having a decentralized trust model eliminates single point of failure. Having a real time traceability enhances your incident response. Real world example? Well, to prepare for the future threat of quantum computing, some government and organizations are experimenting with post quantum cryptography. Example, NIST post quantum cryptography project, wherein NIST is leading an initiative to standardize quantum resistant encryption algorithms. Organizations like Google and Microsoft are already testing post quantum cryptography in experimental TLS handshake and secure messaging apps. What's the impact? Well, it ensures long term confidentiality for data with extended lifespan. Could be health record or military document. It begins transitioning public key infrastructure to post quantum safety. Other notable technologies are digital twins, which is simulate security of physical environment, 5G network slicing, which is segregating virtual networks into enhanced isolation and controls, homomorphic encryption, which enables computing on encrypted data without decrypting it, secure multi-party computation, which is allowing parties to jointly compute a function over their input while keeping them private, zero knowledge proofs, used for identity validation without revealing personal data. Threat modeling and attack surface management. Threat modeling methodologies include STRIDE, DREAD, PASTA, or MITRE attacks and CAPEAC. Architectural risk assessment include risk-based architecture decisions, secure design reviews. Application of threat intelligence, well, contextualizing architecture with threat data. Methodology. Well, threat modeling is the process of thinking through how an attacker might try to compromise a system. These models help prioritize threats so that the most serious one can be added first. Tools like data flow diagrams are often used in threat modeling to visualize how data moves and where weakness may exist. It helps security team understand what needs to be protected and how it might be attacked. Common method includes STRIDE, which is a model that helps identify 6 types of threats: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. DREAD is a method used to rate threat based on damage, reproducibility, exploitability, affected user, and discoverability. FASTA, or process of attack simulation and threat analysis, is a step-by-step approach that maps business impact to technical risk. Threat modeling is a proactive process used in system designs and security engineering to identify, evaluate, and mitigate potential threats before they are exploited. STRIDE, it focuses on six threats we discussed earlier. THREAD, used to rank threat by damage, reproducibility, exploitability, affected user, discoverability. FASTA is a risk-centric, attacker-focused methodology. Attack trees is a visual diagram mapping attack paths to a goal. LIND-DONE, a privacy threat modeling method focusing on data protection. A theoretical example, a security team is designing an online banking portal. They apply STRIDE model to identify the threat. Under spoofing, attackers impersonate a user using stolen credentials. So they can use this as to identify the threat. Under tampering, they look at how a user will try to alter account balance through API manipulation. Under repudiation, they will try to look at if a user can deny making a fund transfer. There is no login available. Under information disclosure, sensitive user data are exposed to misconfigured APIs. They will look at it for this scenario. From a denial of service perspective, malicious traffic overwhelming the login endpoints. So how that threat can be addressed? From elevation of privilege perspective, regular user access admin features through insecure logic. If that is the case, how it can be addressed? The outcome, the team implements MFA to prevent spoofing. They implement input validation to prevent tampering. They build in strong audit login. They secure transmission and encryption for data. They rate limit and capture to mitigate DOS. They enable role-based access control to prevent privilege escalations. Let's look at FASTA in a real-world case. A hospital is migrating its patients' record from system to cloud. Security architecture apply FASTA methodology over the 7 stages. When defining business objective, they look at to protect patient data, whether it's meeting HIPAA compliance. When defining technical scope, they identify cloud assets. What are the cloud assets? When it's about application decomposition, they map out how data flow between components. From a threat analysis perspective, they identify attackers and attack vectors. From a vulnerability analysis perspective, they audit softwares and configurations for weaknesses. From an attack simulation perspective, they test how an attacker might exploit exposed APIs. From risk mitigation perspective, they prioritize encryption, access controls, and monitoring related items. The result, the hospital avoids common pitfalls in cloud security by planning with security in mind from start. Summary of methodology. STRIDE, the focus area is threat categorization. It's easy to apply during the design. FASTA, the focus is risk and attacker centric. Attack tree is visual and goal oriented. And LIND-DONE is focus area is privacy and data centric threats. With this, we come to an end of part 12. I hope this helped you in some way. Do share if anyone else you think can benefit from this. Do subscribe if you think this has helped you and you would like to know about any new videos that comes up. Do like and subscribe. This is your host Savit Vittal Salian. See you in part 13. Namaskar.